Welcome, dear traveler. Tonight, there is nowhere to rush, nothing to solve, and nowhere you need to be except here, quietly listening as we drift together through the greatest story ever told. It is a story so vast that every mountain, every ocean, every star, and every living creature is only a tiny chapter within it. It is the story of our universe. As you settle into a comfortable position, allow your breathing to become slow and steady. Imagine that each gentle breath carries you farther away from the busy moments of the day. With every exhale, the world around you grows quieter. Soon, only the calm rhythm of this journey remains. We are about to travel farther than any spaceship ever could. Not only across unimaginable distances, but backward through time itself. We will pass beyond galaxies, beyond stars, beyond planets, beyond the very beginning of history. Together, we will slowly return to the earliest moments that science can describe. Our journey begins before there were calendars, before there were clocks, before the Earth existed, before the sun had ever begun to shine, long before the first sunrise, long before the first star, long before there was even a place where a star could exist. There was something that is almost impossible for the human mind to imagine. Or perhaps there was nothing at all. Scientists have spent generations trying to understand this mysterious beginning. The deeper they look into the universe, the farther back in time they can see. Powerful telescopes observe galaxies whose light has traveled for billions of years before finally reaching our eyes. Every new discovery acts like another page in an ancient history book, revealing clues about the distant past. Yet eventually, every clue leads toward the same mysterious boundary. A moment when the universe was unimaginably different from the one we know today. It is difficult to picture because our everyday experiences depend on space and time. We measure distances. We count seconds. We watch the sun rise and set. Our brains naturally imagine every event happening somewhere and sometime. But what if there was nowhere? What if there was no one? Before the universe expanded, these familiar ideas may not have existed in any recognizable form. Space itself may not yet have stretched outward. Time itself may not yet have begun flowing. Imagine opening a book only to discover there is no first page because the story begins the instant the book comes into existence. Asking what happened before that moment may be a little like asking what lies north of the North Pole. The question feels natural, yet it may not have an answer within the rules of our universe. Even today, physicists continue exploring this mystery. Some theories suggest our universe emerged from a quantum event. Others imagine cycles of endless universes, each giving birth to another. Some propose hidden dimensions beyond our perception. Others believe many universes may exist together in an unimaginably vast cosmic landscape. The truth is beautifully uncertain, and perhaps that uncertainty makes the beginning even more wonderful. The universe still holds secrets. It reminds us that no matter how much humanity has learned, there are still questions waiting patiently among the stars. If we could somehow travel backward through time, galaxies would slowly move closer together. Distances would shrink. Space itself would become smaller. Every billion years we travel backward, the universe grows hotter, denser, and brighter. Clusters of galaxies merge into crowded regions. Stars disappear into brilliant clouds of glowing gas. Atoms themselves can no longer survive. Eventually, even the particles that make atoms become part of an incredibly hot ocean of energy. Everything we know, the Milky Way, our sun, Earth, every person who has ever lived, every mountain, every drop of water, every grain of sand, would be compressed into a state so tiny and so energetic that it challenges every law of intuition. It is almost impossible to imagine. Yet from this extraordinary beginning came every beautiful thing we have ever known. The story ahead is not only about stars or planets. It is also your story. Every atom of oxygen you breathe, every atom of calcium inside your bones, every atom of iron flowing through your blood. Each one has traveled an astonishing journey across billions of years. Tonight, we will follow that journey together, one peaceful step at a time. There is no need to hurry. After all, the universe has been unfolding for nearly 14 billion years. It can certainly wait a little longer while we simply listen. The universe, as far as science can tell, did not begin with an explosion into empty space. That image is common, but it is not quite accurate. There was no vast darkness waiting to be filled. Instead, space itself began expanding. Every direction, every distance, every corner of what would become the cosmos started to stretch together. It is a remarkable idea. If someone could have been there, which, of course, no one could, the universe would not have looked like a fireball exploding outward from a single point into an empty room. There was no room yet. The room itself was being created. Imagine drawing tiny dots on the surface of an uninflated balloon. As the balloon slowly grows larger, every dot moves away from every other dot. None of the dots sits at the true center of the expansion. From the perspective of each dot, every other seems to drift farther away. Our universe behaves in a surprisingly similar way, though instead of a balloon's rubber surface, it is the fabric of space itself that stretches. This gentle stretching has continued for nearly 14 billion years, and even now, at this very moment, the universe is still expanding. As you lie comfortably listening, countless galaxies are quietly moving farther apart. The room around you feels still, yet on the grandest scales imaginable, the cosmos is slowly growing larger every second. No sound accompanies this expansion. Space does not creak or groan. It unfolds in perfect silence. The earliest instant we can describe is unimaginably brief. Scientists measure it in tiny fractions of a second so small that everyday numbers lose their meaning. In those first moments, temperatures reached levels far beyond anything found inside, even the hottest stars. Matter, as we know it, could not exist. Atoms had not yet formed. Light could not travel freely. There were no planets waiting to cool, no galaxies spinning gracefully through space, and no black holes hidden among distant stars. Instead, everything existed as an extraordinarily energetic sea of fundamental particles and radiation, all interacting in ways that scientists continue to explore today. The laws of nature, however, were already quietly shaping what was to come. Gravity, the force that would one day gather galaxies, was present. The forces that hold atomic nuclei together were present. The forces responsible for electricity and magnetism were present. These invisible rules became the blueprint for everything that followed. It is comforting, in a way, to think that the same laws guiding distant galaxies are also guiding the tiny atoms within your own body. The universe does not need separate instructions for the stars and for us. It follows one elegant set of principles, repeated endlessly across scales both enormous and unimaginably small. For a fleeting instant after the beginning, something astonishing may have happened. The universe appears to have expanded at an incredible speed in an event scientists call cosmic inflation. During this unimaginably brief period, space itself may have grown from something far smaller than an atom to something vastly larger in less than the blink of an eye. It was not that objects raced through space faster than light. Rather, space itself expanded so rapidly that the distances between points increased at an extraordinary rate. If inflation truly occurred, it helped smooth the young universe, making it remarkably uniform. Tiny quantum fluctuations, minute ripples in energy, were stretched across immense distances. Over billions of years, those tiny ripples would become the seeds of galaxies, clusters of galaxies, and eventually the great cosmic web that spans the observable universe. It is amazing to think that the largest structures we see today may owe their existence to fluctuations so small they belonged to the strange world of quantum physics. The quiet spiral of the Milky Way, the brilliant glow of distant galaxies, even the cloud of gas that eventually gave birth to our sun, all may trace their origins back to those almost imperceptible ripples in the newborn universe. In the deepest sense, the grandest patterns in existence may have begun as the gentlest whispers of nature. And as the universe continued to expand, it also began to cool. Slowly, patiently, with each passing moment, the cosmos became a little less chaotic and a little more prepared for the next chapter of its extraordinary story. As the universe continued its gentle expansion, something equally important was happening. With every passing moment, the temperature fell ever so slightly. Although it was still far hotter than the center of any modern star, each tiny drop in temperature allowed nature to reveal another layer of its remarkable design. Imagine taking a pot of glowing molten metal and letting it cool. At first, everything is so hot that no solid shape can exist. But as the temperature gradually decreases, new structures begin to appear. Crystals form, patterns emerge, order quietly replaces chaos. The young universe followed a similar path, though on a scale beyond imagination. During its earliest moments, energy constantly transformed into particles, and particles disappeared back into energy. Tiny building blocks flickered into existence for only the briefest instant before vanishing again. It was a restless cosmic dance, unfolding everywhere at once. Among these newborn particles were quarks, incredibly small entities that remain some of the fundamental ingredients of matter today. They were accompanied by electrons, neutrinos, photons, and many other particles that scientists have discovered through decades of careful experiments. At first, quarks could not settle down. The universe was simply too hot. They rushed freely through the dense sea of energy, unable to combine into anything larger. But the cosmos was patient. As it expanded, the temperature continued to fall. Eventually, the universe crossed an invisible threshold. The heat was no longer intense enough to keep quarks apart forever. Like tiny puzzle pieces finally allowed to fit together, groups of quarks joined to form protons and neutrons. These familiar particles would one day become the hearts of every atom. Every hydrogen atom in a distant galaxy. Every oxygen atom in the air around you. Every carbon atom that forms the cells of your body. All depend upon protons and neutrons that first became possible during these ancient moments. It is comforting to realize that the same particles inside your fingertips have existed, in one form or another, for almost the entire history of the universe. They have traveled across billions of years, through exploding stars, drifting clouds of gas, newborn planets, and living creatures, before finally becoming part of you. The universe is constantly recycling itself. Nothing is truly isolated. Everything is connected through an unimaginably long history. Meanwhile, another kind of particle filled every corner of the expanding cosmos. These were photons, the particles of light. Today, sunlight travels through the emptiness of space with remarkable freedom. It leaves the sun, crosses nearly 150 million kilometers, and reaches Earth in just over 8 minutes. But the early universe was nothing like that. Back then, photons could hardly move at all. Every time a photon tried to travel, it immediately collided with another charged particle. It bounced, scattered, changed direction, and collided again. The universe was so crowded that light could barely make any progress. If you imagine trying to walk through an impossibly crowded festival where every step causes you to bump into someone else, you gain a small sense of what light experienced during those ancient times. The entire universe glowed brilliantly, yet it was also strangely opaque. There was light everywhere, and yet, no one could have seen very far. It was like standing inside a dense golden fog that stretched forever in every direction. As the minutes slowly passed after the beginning, something else extraordinary occurred. Protons and neutrons began joining together inside the intense heat, creating the very first atomic nuclei. Most became simple hydrogen nuclei, consisting of a single proton. Others combined into helium nuclei, containing 2 protons and 2 neutrons. Tiny amounts of lithium also formed, though only in very small quantities. These were the universe's first elements. Nothing heavier existed yet. There was no carbon for future forests, no oxygen for future oceans, no iron for future mountains, no calcium for future bones. The universe's chemical recipe was astonishingly simple. Nearly everything was hydrogen. Most of the rest was helium. The heavier elements that would someday paint autumn leaves in shades of gold, fill gemstones with brilliant colors, and make rocky planets possible had not yet been created. Those wonders would have to wait for the birth and death of stars. For now, the universe remained a vast, glowing ocean of simplicity, carrying within it all the possibilities of the future. The seeds had been planted. The greatest gardens of the cosmos had yet to bloom. The universe had now reached an age of only a few minutes. To us, a few minutes can pass almost unnoticed. They are enough time to brew a cup of tea, watch the clouds drift by a window, or simply close your eyes and enjoy a moment of peace. But during the first few minutes of cosmic history, those quiet moments shaped everything that would follow. The young universe had already expanded enormously since its beginning. Although it remained unimaginably hot, it was cooling steadily, like the fading glow of a great cosmic furnace. The simple atomic nuclei that had formed, mostly hydrogen and helium, floated through an ocean of energetic particles. They could not yet become complete atoms because the universe was still too warm. Electrons moved too quickly to remain attached to them. If an electron briefly settled near a nucleus, another energetic photon would almost immediately knock it away again. The universe was simply not ready. Sometimes, the greatest changes require patience. Nature does not rush. It waits until every condition is just right. For hundreds of thousands of years, the cosmos continued expanding in remarkable silence. There were no stars decorating the darkness, no galaxies turning graceful spirals across space, no planets circling distant suns. no moons reflecting gentle light. Only an immense, glowing sea filled almost entirely with hydrogen, helium, light, and invisible particles that quietly streamed through everything. It might seem strange to imagine a universe without stars, because the night sky has always been filled with them throughout human history. They have guided travelers, inspired poets, and sparked countless dreams. Yet there truly was a time when not a single star existed. The universe knew only light. Not the focused light of a sunrise or the soft glow of a distant galaxy, but a uniform radiance that filled every direction equally. If someone could somehow have stood there, which remains impossible, they would not have seen constellations or planets. They would have been surrounded by a brilliant, glowing haze extending forever. As space continued to stretch, however, the temperature kept falling. Little by little, year after year, century after century, millennium after millennium. Then, nearly 380,000 years after the beginning of our universe, one of the most beautiful moments in cosmic history quietly arrived. The universe had finally cooled enough for electrons to slow down. Instead of racing endlessly through space, they began settling around hydrogen and helium nuclei. For the first time, complete atoms were born. This peaceful event transformed the entire cosmos. Before then, free electrons had scattered nearly every photon that tried to travel. Now, those electrons became safely bound inside atoms. Suddenly, space became transparent. Light, which had spent hundreds of thousands of years bouncing endlessly from particle to particle, was finally free. Imagine opening thick curtains after a long night and watching sunlight pour into a quiet room. The universe experienced something similar, not because a lamp had been switched on, but because the fog had finally lifted. Photons that had been trapped since the universe's earliest moments began traveling across space without interruption. Many of those very same photons are still traveling today. They have crossed nearly 14 billion years of expanding space. Some eventually reached Earth. Others passed our planet without notice. A tiny fraction were collected by sensitive radio telescopes built by curious human beings who wanted to understand where everything began. When scientists detect this ancient light today, they call it the cosmic microwave background. It is often described as the oldest light we can observe, not because it is the first light ever created, but because it is the earliest light that was finally able to travel freely through the universe. Every direction we look in the sky reveals this ancient glow. Whether astronomers point their instruments toward the Milky Way, toward distant galaxies, or toward seemingly empty space, they find the same faint whisper from the young cosmos. It is incredibly gentle now. During its long journey, the expansion of the universe stretched those ancient light waves until they became microwaves, far beyond what human eyes can see. Yet hidden within that faint glow is an extraordinary treasure. Tiny differences in temperature, sometimes only a few millionths of a degree, paint a subtle map across the sky. To most people, it might resemble little more than colorful speckles. But to cosmologists, it is a baby picture of the universe. Those tiny warm and cool patches marked regions where matter was just slightly more crowded than elsewhere. The differences were almost unbelievably small, yet they mattered. Over millions and then billions of years, gravity quietly amplified those gentle ripples. Regions with just a little extra matter pulled in more matter. Slowly, patiently, without making a sound, the first invisible scaffolding of the cosmos began to take shape. From these almost imperceptible variations would eventually emerge vast galaxies, brilliant clusters of stars, graceful spiral arms, and, much later, a small blue planet where someone could lie comfortably in bed, listening to the ancient story of the universe. The light that once escaped into a newborn cosmos still surrounds us tonight. It passes silently through your room, through the walls of your home, and through the emptiness between galaxies. A gentle echo from a time when the universe itself was still an infant, carrying the memory of its earliest dawn. As the oldest light in the universe continued its endless journey across the expanding cosmos, the universe itself entered a long and peaceful chapter that astronomers sometimes call the cosmic dark ages. The name may sound mysterious, perhaps even a little frightening, but there was nothing sinister about this age. It was simply a universe waiting. The brilliant glow that had once filled every direction had faded as space expanded. The ancient light was still there, quietly traveling through the cosmos, but it had stretched into wavelengths invisible to human eyes. The first stars had not yet been born. The heavens, if anyone could have looked upon them, would have appeared almost completely dark, not because light had disappeared, but because the lights of the universe had not yet been switched on. For millions of years, the cosmos rested in extraordinary silence. Hydrogen atoms drifted peacefully through the vastness of space. Helium floated beside them. There were no planets to circle invisible suns, no comets leaving glowing trails, no colorful nebulae decorating the darkness. Only enormous clouds of simple gas stretching across distances so immense that even light needed millions of years to cross them. It might seem that nothing was happening, yet beneath this calm appearance, gravity was quietly at work. Gravity is perhaps the most patient force in nature. Unlike an explosion or a lightning strike, gravity does not hurry. It simply pulls. Always. Every tiny region that contained just a little more matter than its surroundings began attracting nearby gas. At first, the change was almost impossible to notice. A cloud became ever so slightly denser. A neighboring cloud drifted a little closer. Another followed. Over thousands of years, almost nothing seemed different. Over millions of years, everything slowly changed. The universe teaches us that some of the greatest transformations happen so gradually that no single moment feels dramatic. Instead, countless tiny changes quietly add together until an entirely new chapter begins. The growing clouds of hydrogen became larger and heavier. As gravity pulled more gas inward, the centers of these clouds became denser. The particles inside began colliding more often. Each collision created a little heat. As more gas gathered, the pressure increased. The temperature climbed steadily. Imagine gently squeezing your hands together on a cold winter morning. You can feel a small amount of warmth. Now imagine gravity squeezing an enormous cloud containing millions of times the mass of our sun. The warming becomes extraordinary. The cloud continued collapsing under its own weight. Its center became hotter, brighter, denser. For millions of years, gravity patiently built an invisible engine. Then, at last, nature reached another beautiful threshold. Deep inside one of these enormous clouds, the temperature rose to millions of degrees. Hydrogen nuclei, which normally repel one another because they carry positive electric charge, were pushed so close together that an entirely different force of nature took over. They fused. Two tiny nuclei became something new. Eventually, entire groups of stars began shining together. The long cosmic night slowly gave way to a new dawn. These first stars were unlike many of the stars we see today. Because the universe contained almost nothing except hydrogen and helium, they grew to astonishing sizes. Many were dozens or even hundreds of times more massive than our own sun. They burned with incredible intensity. Their brilliant blue-white light flooded the surrounding darkness. Yet such greatness came with a price. The larger a star becomes, the faster it consumes its nuclear fuel. Although these giants were enormous, they lived surprisingly short lives. Some shone for only a few million years, a brief moment compared with the sun, which has already lived for more than 4.5 billion years and still has billions more years ahead. But those first stars had an extraordinary purpose. Inside their blazing cores, they became the universe's first great forges. Hydrogen slowly fused into helium. Helium fused into heavier elements. For the first time in cosmic history, new kinds of atoms began to appear. Carbon, oxygen, neon, silicon. The ingredients for future worlds were being created. The atoms that would one day become forests, oceans, mountains, birds, flowers, and human hearts were first assembled inside these ancient stellar furnaces. Long before Earth existed, long before our sun had begun to shine, the universe was already preparing the materials needed for life. It was a quiet kind of preparation. Patient, steady, almost invisible. Yet every heartbeat you have ever known depends on work that began inside those first brilliant stars, shining alone in a once dark universe, billions upon billions of years ago. The first stars did not shine forever. Even the brightest lights in the universe have their own quiet beginnings, peaceful lives, and inevitable endings. Unlike living creatures, stars do not grow old with wrinkles or gray hair. Their age is measured by the fuel hidden deep within their hearts. As long as hydrogen continues to fuse into helium, a star remains stable, balancing the tremendous pull of gravity with the outward pressure created by its own brilliant energy. For millions of years, these ancient giants maintained that delicate balance. Their light spread across the darkness, traveling farther with every passing second. Photons that left their glowing surfaces began journeys that would last billions of years, crossing immense stretches of expanding space without ever stopping to rest. Some of those ancient rays are still traveling today. The universe is wonderfully patient with light. It allows every photon to continue its voyage until it encounters something in its path, whether that is a drifting cloud of gas, the mirror of a telescope, or the eye of a curious observer. Deep inside the first stars, however, the story was slowly changing. Hydrogen, once abundant, became increasingly scarce. The cores grew hotter. Gravity pressed inward with greater determination. To resist that crushing force, the stars began fusing heavier and heavier elements. Helium became carbon. Carbon helped create oxygen. Oxygen gave rise to neon. Without a fresh source of energy pushing outward, gravity finally gains the upper hand. The enormous star begins collapsing under its own unimaginable weight. What follows is one of the most powerful events in the entire universe. The collapse happens with astonishing speed. The outer layers rush inward. The core becomes denser than anything most people could ever imagine. Then, in a fraction of a second, the collapsing material rebounds outward in a colossal explosion. A supernova is born. For a brief time, a single exploding star can shine more brightly than an entire galaxy filled with hundreds of billions of ordinary stars. Across millions of light years, its light announces that another chapter of cosmic history has unfolded. Yet beyond its breathtaking beauty, a supernova performs an even greater task. The explosion creates conditions so extreme that entirely new elements come into existence. Gold, silver, uranium, lead, nickel, copper. Many of the heaviest elements found throughout the universe owe their existence to these spectacular stellar endings. The gold in a wedding ring, the calcium in your teeth, the iodine that helps the human body function, the copper used in electrical wires, even the tiny traces of rare elements inside your own cells. All were forged in environments so violent that they briefly outshone entire galaxies. It is astonishing to realize that some of the most peaceful things in our daily lives were born from extraordinary cosmic events. The glass of water resting beside a bed, the trees gently moving in the wind, the stones beneath a quiet mountain trail. Every one of them contains atoms that once survived the death of ancient stars. When a supernova fades, it leaves behind more than a beautiful memory. Its explosion scatters newly created elements across enormous distances. Clouds of enriched gas spread through nearby space like seeds carried on a gentle breeze. Over millions of years, these clouds mix with countless others. Slowly, the universe becomes more chemically rich. The second generation of stars forms from this recycled material. Unlike the very first stars, these younger stars inherit carbon, oxygen, silicon, iron, and many other elements from those that came before. The universe has begun to recycle itself. Nothing is truly wasted. The ending of one star quietly becomes the beginning of another. This graceful cycle repeats again and again across billions of years. Stars are born. Stars shine. Stars transform simple atoms into complex ones. Stars return those atoms to space. New stars rise from the remnants. New planets begin to form. Each generation leaves behind a richer universe than the one before. It is a story of quiet inheritance. Every star passes something precious to the next. Every generation builds upon the work of those that came before. In many ways, the cosmos behaves like an endless garden. Old flowers bloom and fade. Their seeds fall gently to the earth. From those seeds, new blossoms appear. The garden is never exactly the same, yet it continues growing, season after season, age after age. So it was with the young universe. What began as a simple sea of hydrogen and helium was slowly becoming a place of astonishing diversity. The ingredients for rocky worlds, sparkling oceans, towering mountains, gentle forests, and living creatures were no longer just possibilities. They were drifting quietly through space, waiting for gravity to gather them once more into something entirely new. Far in the future, one such cloud would begin a journey unlike any before. Within it lay the atoms that would someday become our sun, our Earth, and eventually every one of us. For hundreds of millions of years, the universe continued its quiet rhythm. Stars were born from drifting clouds of gas. They lived brilliant lives, filling the darkness with warmth and light. Eventually, many of them reached the ends of their journeys, returning their precious elements back to space through gentle stellar winds or magnificent supernova explosions. With every generation, the universe became a little richer. The first stars had known almost nothing except hydrogen and helium. But now, the great clouds floating between the stars contained carbon, oxygen, silicon, magnesium, iron, and countless other elements. The cosmic recipe was becoming wonderfully complex. Every atom carried a history. A carbon atom might once have rested inside the glowing heart of a giant blue star. An oxygen atom may have survived a supernova that briefly outshone an entire galaxy. An iron atom could have traveled through empty space for hundreds of millions of years before joining a quiet cloud of gas. The universe wastes very little. Instead, it is constantly recycling itself, reshaping old material into new forms. Astronomers often describe this process as cosmic evolution, not because the universe is alive in the way that plants or animals are, but because it gradually changes over time, becoming more intricate with each passing billion years. As gravity continued its patient work, something remarkable began to appear. Stars no longer formed completely alone. Instead, they gathered into enormous families. These families became the first galaxies. A galaxy is much more than a collection of stars. It is a vast city of light, held together by gravity. Within its borders are stars, planets, clouds of gas, clouds of dust, star clusters, black holes, and mysterious dark matter, all moving together through space in a graceful cosmic dance. Some galaxies became elegant spirals, with bright arms slowly winding around glowing centers. Others settled into smooth, elliptical shapes. Still others collided, merged, stretched, and transformed into forms unlike anything found on Earth. No two galaxies were exactly alike. Each developed its own unique history. Imagine floating far beyond any single galaxy. From that distant viewpoint, the universe would not appear randomly scattered. Instead, galaxies gathered into clusters. Clusters gathered into even larger groups called superclusters. Between them stretched immense filaments of galaxies connected across unimaginable distances, while enormous empty regions, known as cosmic voids, remained almost completely free of galaxies. Together, these structures formed what scientists now call the cosmic web. If we could somehow see the entire observable universe from far away, it might resemble delicate strands of glowing silk woven through an ocean of darkness. Along these invisible threads, galaxies continued their slow journeys, guided by gravity over billions of years. The scale is almost impossible to imagine. Light travels nearly 300,000 kilometers every second. It circles Earth more than 7 times in a single second. Yet, even at that astonishing speed, light requires more than 100,000 years simply to cross our own Milky Way galaxy. Crossing the observable universe would take more than 90 billion light years because space itself has continued expanding while the light traveled. Such numbers are so enormous that they become almost poetic. They remind us that the universe is far greater than our everyday experience allows us to imagine. Among the countless galaxies forming during these ancient ages, one slowly began developing a graceful spiral shape. Its bright arms stretched outward like the delicate curves of a seashell. At its center rested an extraordinarily dense region where millions of stars crowded together around a supermassive black hole. This galaxy would eventually become our home. Today, we know it as the Milky Way. Its story began long before our sun existed, long before Earth cooled, long before the first ocean reflected the sky. The Milky Way itself was assembled piece by piece. Small galaxies drifted nearby. Some passed peacefully. Others were captured by gravity. Over billions of years they merged together, adding new stars to the growing galaxy. Even today, astronomers continue discovering evidence of these ancient collisions. Streams of stars still stretch across the Milky Way like faint rivers, preserving the memory of galaxies that disappeared billions of years ago. In a sense, our galaxy is a collection of many older stories woven into one. It carries the memories of countless generations of stars and galaxies that came before. Near its center, stars orbit rapidly around the hidden supermassive black hole known as Sagittarius A star. Although invisible by itself, its immense gravity guides the motions of nearby stars. Fortunately, our own solar system formed far from this crowded central region. We live about 26,000 light-years from the galactic center, in one of the Milky Way's quieter spiral arms. It is a peaceful neighborhood by cosmic standards. Here, stars are spaced comfortably apart. Violent encounters are relatively rare. Over billions of years, this calm corner of the galaxy would provide the stable environment needed for something extraordinary to happen. Not immediately. The universe was in no hurry. First, another generation of stars had to be born. Another cloud of enriched gas had to begin collapsing. Eventually, it contained almost all of the material in the collapsing cloud. This glowing center was not yet a true star. Astronomers call this stage a protostar. It was the young sun, still forming, wrapped in a swirling cocoon of gas and dust. Around it stretched a vast disk that rotated in perfect silence. Within that disk, tiny grains of dust drifted peacefully. Each grain was astonishingly small. Some were no larger than particles of smoke. Others resembled fine grains of sand. On their own, they seemed insignificant. Yet the universe often creates magnificent things from humble beginnings. As these tiny grains gently collided, many simply bounced apart. Some stuck together. Electrostatic forces helped them cling to one another, forming slightly larger clumps. Those clumps met other clumps. Pebbles formed, then rocks, then objects measured in kilometers rather than centimeters. No one collision created a planet. Instead, millions upon millions of tiny encounters gradually built larger and larger worlds. Nature preferred patience over speed. The spinning disk became crowded with growing bodies. Some reached the size of mountains. Others became hundreds of kilometers across. Gravity now began helping these larger objects gather even more material. Like gentle collectors drifting through the disk, they swept up smaller rocks wherever they traveled. Over millions of years, these growing worlds became known as planetesimals. They were the first true building blocks of planets. The early solar system was far from peaceful. Although the process unfolded over immense periods of time, collisions happened constantly. Some impacts were gentle enough for objects to merge. Others were powerful enough to shatter entire worlds into countless fragments. Every collision reshaped the future. Nothing followed a perfectly straight path. Instead, the solar system slowly organized itself through millions of years of quiet construction and occasional dramatic impacts. Closer to the young sun, temperatures remained extremely high. Only metals and rocky minerals could survive. Ice quickly melted and evaporated. Farther away, where sunlight was weaker, frozen water, methane, and ammonia could remain solid. This simple difference in temperature would determine the kinds of planets that eventually formed. Near the sun, 4 rocky worlds slowly emerged: Mercury, Venus, Earth, Mars. Far beyond them, enormous planets gathered vast amounts of hydrogen and helium before the remaining gas disappeared from the disk. These became the giant worlds we know today. Jupiter, the largest of them all, grew so massive that more than 1,000 Earths could fit inside it. Saturn surrounded itself with magnificent rings that would one day inspire generations of skywatchers. Uranus quietly rotated on its side. Neptune settled into the cold outer reaches of the solar system, where sunlight is little more than a distant glow. Meanwhile, countless smaller objects remained behind. Some became asteroids. Others became icy comets that would spend billions of years traveling graceful paths around the sun. Many preserved the original material from which the solar system formed, acting like tiny time capsules carrying memories of its earliest days. At the center of it all, the young sun continued growing hotter. Gravity squeezed its core ever tighter. The temperature climbed into the millions of degrees. Then, after countless ages of preparation, another invisible threshold was crossed. Hydrogen nuclei began fusing into helium. An immense flood of energy was released. The sun was finally born. Its first true light spread across the newborn solar system. The long night inside the spinning cloud had ended. A new star now illuminated the worlds forming around it. Among those young worlds was one that looked nothing like the peaceful blue planet we know today. It was dark, molten, violent. Its surface glowed with rivers of liquid rock. Great impacts shook it again and again. No oceans reflected the sunlight. No forests whispered in the wind. No living creature had yet taken its first breath. And yet, this restless young world already carried within it every possibility of the future. This world was Earth. Its greatest adventures were only just beginning. The young Earth was a world of fire. If you could have stood upon its surface during those earliest days, you would not have found quiet forests, gentle rivers, or cool mountain air. In truth, you could not have stood there at all. The ground itself was unstable. Rivers of molten rock flowed across enormous landscapes. Volcanoes rose and erupted with astonishing power. The sky glowed with heat. Everywhere, the planet was still releasing the energy left over from its violent birth. It was a beautiful kind of chaos. Not the chaos of disorder, but the chaos of creation. Earth was still becoming itself. Every collision that had helped build the young planet had generated tremendous heat. Radioactive elements hidden within its interior added even more warmth. Gravity continued squeezing the planet's center with immense pressure. Together, these forces transformed much of the early Earth into a glowing ocean of liquid rock. Yet even in this fiery beginning, gravity was quietly organizing the planet. The heaviest elements slowly drifted downward. Iron and nickel sank toward the center. Lighter materials floated upward. Over millions of years, Earth separated itself into distinct layers. At its heart formed a dense metallic core. Around it developed a thick mantle of slowly flowing rock. Above that, a thin crust gradually began to cool. Although we often imagine our planet as solid and unchanging, Earth is still layered much as it was billions of years ago. Far beneath your feet, the core remains unimaginably hot. It quietly powers many of the geological processes that continue shaping our world today. The movement of continents, the rise of mountains, the eruption of volcanoes. Even Earth's protective magnetic field begins deep within this hidden interior. Even after tremendous destruction, nature found a way to create something beautiful. In its earliest days, the moon orbited much closer to Earth than it does now. It would have appeared enormous in the sky, many times larger than today's full moon. Its presence created enormous tides across Earth's still-forming surface. Those tides gently influenced the young oceans that would appear much later. Even today, the moon continues its quiet dance around our planet. Each year, it slowly drifts about 4 centimeters farther away. The change is so small that no person notices it during a lifetime. Yet over hundreds of millions of years, the distance becomes significant. The universe reminds us once again that great changes often happen through tiny movements repeated patiently over immense spans of time. As Earth continued cooling, something equally remarkable began to happen. The thick blanket of gases released by countless volcanoes slowly surrounded the planet. This early atmosphere looked nothing like the one we breathe today. There was almost no oxygen. Instead, it contained large amounts of water vapor, carbon dioxide, nitrogen, methane, and other gases rising from Earth's fiery interior. The sky would have appeared strange to modern eyes. No birds crossed it. No clouds floated peacefully overhead as they do today. Yet hidden within this ancient atmosphere was one ingredient that would soon transform the planet forever. Water. At first, it remained suspended as hot vapor because Earth's surface was still too warm for liquid oceans. But as millions of years passed, temperatures slowly fell. The crust cooled. The skies changed. Then, one quiet day in Earth's unimaginably long history, the first raindrops began to fall. Not for an afternoon, not for a season, perhaps not even for a century. Many scientists believe rain fell for thousands, perhaps even millions of years. The clouds poured endlessly upon the cooling world. Water collected in low places. Tiny pools became lakes. Lakes merged into vast seas. The first oceans slowly covered much of the planet. For the first time, sunlight reflected from calm water instead of glowing rivers of lava. Earth had taken another peaceful step toward becoming the blue world we know today. No fish swam beneath those ancient waves. No coral reefs colored the shallow seas. No whales sang through the deep. The oceans were silent. Yet within those quiet waters, chemistry was beginning a story even more astonishing than the birth of stars or planets. Somewhere beneath those restless waves, perhaps near warm volcanic vents on the seafloor, perhaps in shallow pools warmed by the young sun, nature was preparing for an entirely new chapter. The universe had spent nearly 10 billion years creating stars, galaxies, planets, and oceans. Now, for the very first time, it was about to explore something completely different. Life. The first oceans were unlike the seas we know today. There were no coral reefs glowing beneath clear blue water. No schools of fish moving together like shimmering clouds. No whales singing through the depths. No dolphins leaping above the waves. The young oceans were quiet. They stretched across a world that still looked both beautiful and unfamiliar. The water carried dissolved minerals washed from freshly formed rocks. Volcanoes continued releasing gases into the atmosphere. Lightning flashed across the skies. The young sun shone slightly dimmer than it does today, yet Earth remained warm enough for liquid water to cover much of its surface. Somewhere within these ancient oceans, chemistry continued its patient work. The universe had already demonstrated extraordinary creativity. It had transformed energy into particles, particles into atoms, atoms into stars, stars into heavier elements, elements into planets. Now, it seemed ready for another remarkable transformation. Scientists are still trying to understand exactly how life first began. It remains one of the greatest mysteries in all of science. Unlike the birth of stars, which we can observe throughout the universe, the origin of life may have happened only once on Earth, or perhaps many times before one version finally endured. No one knows with complete certainty, and perhaps that mystery makes the story even more fascinating. One possibility is that life's earliest building blocks formed in shallow pools where sunlight, rain, and lightning constantly interacted with simple chemicals. Another idea points toward deep-sea hydrothermal vents, where hot mineral-rich water flowed from cracks in the ocean floor. Even today, these remarkable places support thriving ecosystems without relying on sunlight. Tiny organisms there obtain energy directly from chemical reactions, reminding us that life can flourish in surprising environments. Perhaps the earliest living systems discovered a similar path billions of years ago. Whatever the location, nature worked patiently. Simple molecules combined into more complex ones. Those combined into larger structures. Some became capable of storing information. Others helped speed up chemical reactions. Eventually, certain collections of molecules gained an extraordinary ability. They could make copies of themselves. It may not have happened all at once. There was probably no single magical moment when a lifeless world suddenly became alive. Instead, countless small changes likely accumulated over immense spans of time. Each tiny improvement made the next one possible. Gradually, chemistry became biology. The lines separating the two may have been so gentle that no clear boundary existed. Then, somewhere in those ancient waters, the first true living cells appeared. It learned, not through conscious thought, but through evolution. Tiny variations appeared in each new generation. Some changes proved helpful. Others disappeared. The organisms best suited to their surroundings produced more descendants. Slowly, almost imperceptibly, life became more capable of surviving the ever-changing world. Nature did not plan ahead. It simply preserved what worked. Over millions upon millions of years, this gentle process transformed simple cells into increasingly complex forms. One of the most extraordinary innovations was still waiting to appear. Some ancient microorganisms discovered how to capture energy directly from sunlight. Instead of relying only on chemicals dissolved in the water, they began using the light of the sun itself. This remarkable process is known today as photosynthesis. At first, it may have seemed like a small change, but its consequences would reshape the entire planet. These tiny organisms quietly released a gas that had been almost absent from Earth's atmosphere: oxygen. For a long time, the oxygen reacted with iron dissolved in the oceans, creating vast deposits of iron-rich rocks that still exist today. Eventually, however, the oceans could absorb no more. Oxygen slowly began accumulating in the atmosphere. The sky itself was changing because of creatures too small to be seen with the naked eye. The universe often reminds us that greatness is not always measured by size. Sometimes, the smallest lives create the largest transformations. Those ancient microscopic architects were unknowingly preparing Earth for a future they could never imagine. A future filled with forests, flying birds, roaring waterfalls, snow-covered mountains, curious minds, and quiet evenings when someone could look up at the stars, breathe gently, and listen to the timeless story of the universe unfolding once more. The rise of oxygen was one of the quietest revolutions in the history of our planet. There were no loud celebrations, no sudden flashes of light visible from space, no single day when the world looked completely different. Instead, The transformation unfolded so gradually that millions of generations of tiny organisms lived and disappeared before the change became truly noticeable. Drop by drop, bubble by bubble, breath by breath, the atmosphere slowly began filling with oxygen. For many of the earliest forms of life, oxygen was not a gift. It was a challenge. Many ancient microorganisms had evolved in a world where oxygen was almost absent. To them, this new gas was highly reactive and even poisonous. Some species disappeared forever. Others retreated to places where oxygen remained scarce, deep beneath the ocean floor or hidden within layers of mud and rock. Even today, descendants of those ancient organisms continue living in environments almost unchanged from the distant past. Earth, in a sense, still preserves tiny memories of its earliest ages. Yet while some forms of life struggled, others discovered something extraordinary. They learned to use oxygen as a powerful source of energy. This new way of living was remarkably efficient. Cells could produce far more energy than before. With more energy available, life suddenly gained new possibilities. Larger cells became practical. The tiny guest produced energy. The larger host offered protection. Over countless generations, their partnership became permanent. Today, nearly every complex cell on Earth carries descendants of that ancient partnership. Those tiny energy-producing structures are called mitochondria. They work tirelessly inside almost every cell of your body. Right now, as you listen to this story, inside your muscles, inside your heart, inside your brain, billions upon billions of mitochondria are quietly transforming food and oxygen into the energy that keeps you alive. They are living reminders of a partnership that began nearly 2 billion years ago. It is astonishing to think that every heartbeat carries the legacy of such an ancient alliance. Nature often discovers that cooperation is just as powerful as competition. As the ages continued to pass, Earth's continents slowly drifted across the surface of the planet. The ground beneath our feet may feel perfectly still, but the continents have never truly stopped moving. They float upon the slowly flowing rocks of the mantle beneath them. The movement is incredibly slow, only a few centimeters each year, about as fast as your fingernails grow. Yet given enough time, even the slowest journeys become extraordinary. Oceans opened, mountains rose. Other mountains slowly wore away beneath wind and rain. Entire continents collided before drifting apart once again. The Earth was quietly reshaping itself. Meanwhile, life continued experimenting. Some cells learned to work together in colonies. Instead of living alone, they formed simple communities. Over immense spans of time, these communities became more organized. Different cells began performing different jobs. Some gathered food. Others provided structure. Some specialized in reproduction. The first multicellular organisms had appeared. This was another turning point in the history of life. Until now, every living thing had been microscopic. Now, organisms could become large enough to be seen without a microscope. Soft-bodied creatures drifted through ancient seas. Some resembled delicate ribbons. Others looked like flattened leaves resting upon the seafloor. Many were unlike anything alive today. They belonged to experiments in evolution that have long since disappeared. The oceans were becoming more diverse with each passing million years. Still, compared with the richness of modern life, Earth remained wonderfully quiet. There were no fish with jaws, no trees reaching toward the sky, no insects buzzing through forests, no birds singing at dawn. The land itself remained almost completely barren. If you had walked across an ancient shoreline, you would have found bare rocks, gentle waves, and empty landscapes stretching to the horizon. The greatest variety of life still lived beneath the surface of the sea, yet the stage was slowly being prepared. The atmosphere now contained enough oxygen to support larger and more active creatures. The oceans held increasing amounts of nutrients. The continents continued changing shape, creating new coastlines and shallow seas. Every piece of the puzzle was quietly falling into place. Nature was taking its time. It had already spent billions of years preparing the universe before creating the first stars. It had spent billions more preparing Earth before creating the first cells. Now it would spend hundreds of millions of additional years preparing life for its next great leap. Soon, the oceans would burst into an astonishing explosion of diversity. Creatures with eyes would look upon the world for the very first time. Some would swim, some would crawl, some would hunt, some would hide. The quiet seas that had long belonged to microscopic life were about to become filled with extraordinary new forms. The story of the universe was no longer only the story of stars and galaxies. It had become the story of living worlds. And on one small blue planet orbiting an ordinary star, life was preparing to dream bigger than ever before. For nearly 3 billion years, life had remained wonderfully simple. The oceans were filled with microscopic organisms carrying out their quiet routines beneath the waves. They grew, divided, adapted, and slowly changed from one generation to the next. The process was almost unimaginably slow, yet it never truly stopped. Then, around 540 million years ago, something extraordinary began to unfold. To a human observer, it might have seemed sudden. To the universe, it was simply the next gentle step. Scientists call this remarkable period the Cambrian explosion. Despite its dramatic name, it was not an explosion in the ordinary sense. There was no deafening sound, no great flash visible across the planet. Instead, over tens of millions of years, life began experimenting with an astonishing variety of new forms. The oceans, once inhabited mostly by tiny and simple creatures, became filled with animals unlike anything that had existed before. Some developed hard shells for protection. Others grew long, flexible bodies that allowed them to swim gracefully through the water. Many evolved powerful jaws capable of grasping food. Others protected themselves with sharp spines or thick armored plates. For the first time, predators and prey began shaping one another's evolution. One species became faster. Another became better at hiding. Some learned to burrow beneath the seafloor. Others developed stronger senses to detect danger. It was as though nature had suddenly discovered an endless collection of new ideas. Perhaps the greatest innovation of all was the evolution of eyes. Before eyes existed, life experienced the world through touch, chemistry, and simple sensitivity to light and darkness. Now, certain creatures could actually see. The first images ever perceived by living beings may have been little more than blurred shadows moving through shallow seas. Yet even those simple glimpses transformed everything. A creature that could detect an approaching predator had a better chance of surviving. One that could spot food from farther away gained a valuable advantage. Generation after generation, vision became sharper. The universe had spent billions of years creating light. Now, for the first time, there were living eyes capable of appreciating it. It is a beautiful thought. Stars had illuminated the cosmos for countless ages. Sunlight had reflected from Earth's oceans for hundreds of millions of years. But only now did life begin looking back. Some of the earliest animals seem almost alien to us today. One of them was Anomalocaris, a graceful swimmer with large compound eyes and long grasping appendages. Another was Hallucigenia, whose unusual appearance puzzled scientists for decades. There was also Opabinia, an animal with 5 eyes and a flexible trunk unlike anything alive today. These creatures remind us that evolution does not follow a predetermined path. Nature explores countless possibilities. Some designs endure for hundreds of millions of years. Others vanish, leaving behind only fossils hidden within ancient rocks. The fossil record acts like Earth's memory. Every layer of stone preserves tiny fragments of stories from worlds long gone. A shell pressed into soft mud. The footprint of an animal crossing an ancient shoreline. The delicate imprint of a leaf that drifted into calm water. Together, these fossils allow scientists to reconstruct chapters of history that no human ever witnessed. Each fossil is a quiet letter sent across immense stretches of time. As life became increasingly diverse, the oceans grew more vibrant. The food web became more intricate. Every species depended, in some way, upon countless others. It is easy to imagine nature as a collection of separate creatures. Yet from the very beginning, life has always been deeply connected. Every organism influences another. Every change ripples outward. The universe seems to delight in creating networks rather than isolated things. This pattern appears everywhere. Stars gather into galaxies. Galaxies gather into clusters. Cells gather into organisms. Organisms gather into ecosystems. Connection is one of the universe's quietest themes. Meanwhile, above the oceans, the continents continued drifting slowly across Earth's surface. They collided and separated with remarkable patience. Towering mountain ranges rose where continents met. Wind, rain, and rivers gradually wore them down again. Even the mightiest mountains are temporary visitors in Earth's history. The planet itself is constantly renewing its surface. What seems permanent during a human lifetime often proves fleeting over hundreds of millions of years. The atmosphere also continued changing. Oxygen levels slowly increased. The protective ozone layer became stronger high above the planet. This invisible shield absorbed much of the sun's harmful ultraviolet radiation. Without it, life would struggle to survive on land. Although the continents still appeared mostly barren, the conditions were quietly improving. The stage was almost ready for another extraordinary adventure. For billions of years, life had remained almost entirely confined to the oceans. Water had been its cradle, its shelter, its entire world. Soon, however, a few brave descendants of those ancient sea dwellers would begin exploring an entirely new frontier. For the first time, living organisms would leave the safety of the oceans and venture onto the silent, empty land. The continents, which had waited patiently since Earth's earliest days, were finally about to welcome life. The first steps onto land were among the quietest adventures in the history of life. There were no cheering crowds, no great celebrations, only a vast, silent world waiting patiently. For billions of years, the continents had stood beneath the sky, almost completely empty. Rain fell upon bare rocks. Rivers carved valleys through lifeless landscapes. Winds shaped cliffs that no living eyes had ever seen. The land was beautiful, but it was lonely. Life had remained safely within the oceans, where water protected delicate cells from drying out and softened the warmth of the sun. Leaving that familiar home was not easy. The air was dry, Gravity felt stronger without the support of water. Sunlight was brighter. The ground offered new challenges that no organism had faced before. Yet nature has always been wonderfully curious. Given enough time, it explores every opportunity. The earliest pioneers were not towering trees or flowering plants. They were tiny communities of microorganisms living on damp rocks and muddy shorelines. Simple bacteria and algae slowly spread across places where moisture lingered after the tides retreated. These humble colonies quietly prepared the land for everything that would follow. Little by little, they helped break down bare rock. Minute particles collected. Primitive soils began forming. It was a slow transformation, one so gradual that millions of years passed before noticeable changes appeared. Then came some of the first true plants. They were nothing like the forests we know today. They had no flowers, no seeds, no fruits. Many were only a few centimeters tall, resembling delicate green carpets spreading across moist ground. Instead of deep roots, they anchored themselves with simple thread-like structures. Instead of colorful blossoms, they reproduced by releasing tiny spores into the air. Yet despite their modest appearance, these early plants performed an extraordinary service. They captured sunlight, they absorbed carbon dioxide, and they released oxygen. Earth was keeping its diary. Soon, another remarkable group of animals would make a journey almost as daring as the first plants had. Some adventurous fish would discover that the shallow edges of rivers and swamps offered new opportunities. Their fins would gradually become stronger. Their lungs would become more useful. One careful movement at a time, they would begin climbing onto land. From those hesitant pioneers would eventually come amphibians, reptiles, dinosaurs, birds, mammals, and, after an unimaginably long journey, us. The universe was still telling its story, and every new chapter seemed even more astonishing than the last. The first animals to leave the water could never have imagined how important their journey would become. For countless generations, their ancestors had lived entirely beneath the surface of ancient seas and winding rivers. Water had carried their weight, surrounded their bodies, and provided the oxygen they needed to survive. The land was another world entirely. The air could not support them. The sun warmed the ground more intensely. Streams sometimes dried. Food was scattered in unfamiliar places. Yet hidden among these challenges were opportunities waiting to be discovered. During certain seasons, shallow pools evaporated beneath the warm sky. Fish trapped within them faced a difficult choice. Some perished as the water disappeared. Others survived long enough to reach deeper pools nearby. Individuals with slightly stronger fins could push themselves across wet mud a little farther than others. Those with simple air-breathing organs gained another advantage when oxygen became scarce in warm, shallow water. Generation after generation, these small differences accumulated. Nature was not working toward a grand plan. It simply preserved the variations that helped living creatures survive. Over millions of years, fins slowly became stronger. Bones inside them changed shape. Muscles became more powerful. Primitive lungs improved. The descendants of those ancient fish gradually transformed into the first amphibians. They could still return to the water whenever they wished. Their eggs still depended upon moist environments. Yet they had accomplished something extraordinary. They had become citizens of two worlds. Imagine standing beside an ancient swamp more than 350 million years ago. The air feels warm and humid. Towering ferns sway gently in the breeze. Giant horsetails rise toward the sky like living pillars. Dragonflies larger than modern birds glide silently above quiet pools. Then, from the edge of the water, a curious creature slowly lifts itself onto the muddy shore. Its movements are careful, uncertain. Every step is an experiment. It pauses for a moment before continuing forward. That simple walk represents one of the greatest journeys in the history of life. Every animal that has ever walked, run, climbed, burrowed, or leaped across the land traces its ancestry back to pioneers like these. The forests continued growing richer. As plants spread across the continents, they absorbed enormous amounts of carbon dioxide from the atmosphere. Some eventually died and became buried beneath layers of mud and sediment. Over immense spans of time, heat and pressure transformed much of this ancient plant material into coal. Today, many of the world's coal deposits are quiet reminders of forests that flourished hundreds of millions of years before the first dinosaur appeared. It is remarkable to think that the warmth from a fireplace or the electricity generated from coal can sometimes trace its origins back to sunlight captured by leaves in forests older than almost anything we can imagine. Meanwhile, evolution continued exploring new possibilities. Some amphibians gradually became less dependent upon water. A remarkable innovation appeared. Instead of laying delicate eggs that needed ponds or streams, certain animals evolved eggs protected by sturdy shells. Inside each egg was a tiny self-contained world. Food, water, protection, everything a developing young animal needed. This single adaptation opened vast new territories. Creatures no longer had to remain close to lakes or rivers. They could travel across dry landscapes, explore deserts, climb hills, spread into environments that had previously been impossible to inhabit. These pioneers became the first true reptiles. Their descendants would eventually dominate Earth for an astonishing length of time. But before that age arrived, the continents themselves were changing once again. Slowly, almost imperceptibly, Earth's drifting land masses began moving toward one another. Year after year, century after century, million after million years, the gaps between continents narrowed. Oceans slowly closed. Mountain ranges rose where enormous plates collided. Finally, nearly all of Earth's major land masses became joined together into one immense supercontinent. Scientists call it Pangaea. Imagine standing upon this ancient world. Without crossing an ocean, it would have been possible, given enough time, to walk across enormous stretches of connected land. Deserts spread across the interior. Mountain chains stretched for thousands of kilometers. The coastline curved around a single vast continent surrounded by one great global ocean. The climate varied dramatically from place to place. Some regions received abundant rainfall. Others remained dry for long ages. These changing environments encouraged even greater diversity among living creatures. Every new habitat presented fresh challenges. Every challenge inspired new adaptations. Life continued responding with endless creativity. Tiny changes accumulated over countless generations. Claws became stronger. Teeth became sharper. Legs became faster. Senses became more refined. The story of life had become one of constant innovation. Yet through all these transformations, the stars above remained familiar. Night after night, the moon continued circling Earth. The planets followed their quiet paths around the sun. The Milky Way stretched across the darkness. The universe watched patiently as one small world continued its remarkable experiment with life. Soon, another chapter unlike any before would begin. A group of reptiles would evolve into creatures of astonishing size and variety. Some would grow longer than city buses. Others would become swift hunters. Some would develop feathers long before birds filled the skies. For more than 160 million years, they would shape Earth's landscapes in ways that still capture our imagination today. The age of the dinosaurs was quietly approaching. The arrival of the dinosaurs was not a sudden event. There was no single morning when Earth awakened to find giant reptiles wandering across its forests. Nature rarely works that way. Instead, countless generations slowly changed, each one differing only slightly from the one before it. Over millions upon millions of years, those tiny differences accumulated until entirely new kinds of animals appeared. The ancestors of the dinosaurs were relatively small creatures. They walked through landscapes that were already home to many other reptiles, amphibians, insects, and early relatives of mammals. At first, they were simply one group among many. Nothing suggested they would someday become the rulers of the land. But the history of life has often been shaped by unexpected opportunities. Around 252 million years ago, long before the dinosaurs reached their greatest diversity, Earth experienced the largest mass extinction ever known. Scientists call it the Permian-Triassic extinction. It was so immense that roughly 90% of marine species and a large proportion of life on land disappeared. The exact causes are still being studied, but enormous volcanic eruptions, dramatic climate change, warming oceans, and declining oxygen levels likely worked together over long periods. The planet became a far more difficult place to survive. Yet even during this difficult chapter, life endured. Some species disappeared forever. Others adapted. Those survivors became the ancestors of future ecosystems. It is one of nature's quiet lessons. Endings, though often heartbreaking, can also become the beginnings of entirely new stories. As millions of years passed after that great extinction, dinosaurs slowly diversified. Some remained small enough to dart through the undergrowth. Others became larger with every generation. Their legs carried them efficiently across great distances. Their lungs supplied abundant oxygen. Their bodies proved remarkably well suited to many different environments. Eventually, dinosaurs spread across nearly every continent. The Earth they inherited looked very different from today's world. The continents were still connected in ways that modern maps no longer show. Warm climates reached much farther toward the poles. Dense forests covered enormous regions. Fern-filled valleys stretched beneath towering conifer trees. Flowering plants had not yet transformed the landscape. Instead, ancient cycads, ginkgos, and giant conifers dominated the forests. The air carried unfamiliar scents. The sounds were unlike any heard today. There were no songs of robins or sparrows. No buzzing bees visiting flowers. Instead, insects hummed among primitive plants while reptiles of every size moved quietly through the vegetation. Some dinosaurs remained surprisingly small. Others became astonishing giants. Among the largest were the long-necked sauropods. Imagine standing quietly beside one of these peaceful giants. Its neck rises higher than the roof of a modern house. Its body outweighs dozens of elephants. Each slow footstep gently shakes the ground beneath you. Yet despite its immense size, it spends much of its day calmly feeding on leaves high above the forest floor. Nature reminds us that great size does not always accompany great aggression. Many of the largest dinosaurs were gentle plant eaters. Nearby, predators watched the forests with patient eyes. Large meat-eating dinosaurs evolved powerful jaws, sharp teeth, and excellent senses. They did not hunt constantly, like modern lions or wolves. They likely spent much of their lives resting, conserving energy between successful hunts. The fossil record often emphasizes dramatic moments. Yet most days in the age of dinosaurs were probably peaceful. Herds grazed quietly. Young animals stayed close to their parents. Rivers flowed steadily toward distant seas. Rain fell upon ancient forests just as it does today. The ordinary days vastly outnumbered the extraordinary ones. As the millions of years unfolded, dinosaurs continued changing. Some developed elaborate horns. Others grew protective armor. A few evolved magnificent crests upon their heads, perhaps used for communication or display. Nature seemed endlessly creative. One of the most remarkable discoveries made by modern paleontologists is that many dinosaurs were not covered only with scales. Some possessed feathers. At first, these simple feathers probably helped keep their owners warm. Later, they became useful for display. Eventually, in one remarkable branch of the dinosaur family, feathers made something entirely new possible. Flight. The first true birds evolved from small feathered dinosaurs. This idea once seemed almost unbelievable. Today, abundant fossils beautifully preserve the gradual transition. Tiny wishbones, feather impressions, lightweight skeletons, grasping hands that slowly transformed into wings. When you hear a bird singing outside your window, you are listening to the distant descendants of creatures that once shared the earth with mighty dinosaurs. In a very real sense, dinosaurs never completely disappeared. They still greet each sunrise from tree branches, rooftops, forests, and city parks around the world. The skies carry echoes of an ancient age. Meanwhile, hidden beneath the feet of these great reptiles lived another group of animals. They were small, mostly active at night. Many resembled tiny shrew-like creatures. Compared with the enormous dinosaurs surrounding them, they seemed almost insignificant. These were the earliest mammals. They quietly searched for seeds, insects, and small prey beneath the cover of darkness. Few would have guessed that these humble creatures represented the future. Sometimes, the universe hides its greatest possibilities in its smallest beginnings. For over 160 million years, dinosaurs shaped the landscapes of Earth. Generations came and went. Continents drifted apart. Mountains rose and slowly wore away. The moon continued its endless orbit. The stars shone above every ancient night. The age of dinosaurs seemed almost eternal. Yet even the longest chapters eventually reached their final pages. Far beyond Earth, in the quiet darkness between the planets, a mountain-sized traveler had already begun a journey that would forever change the history of life. It moved silently through space. For millions of years, it followed its orbit around the sun. No living creature on Earth knew it was coming. The universe, however, was already turning the page toward another extraordinary chapter. Far beyond the orbit of Mars, a solitary world of rock and metal traveled quietly around the sun. It had no forests, no rivers, no sky filled with clouds. It was simply another ancient remnant left over from the birth of the solar system, following an orbit that had remained largely unchanged for millions of years. For ages beyond counting, its journey seemed uneventful. Each orbit carried it through the silent darkness of space. The sun rose and set across its barren surface. Nothing suggested that this lonely traveler would one day alter the history of an entire planet. But the universe is filled with paths that occasionally cross. About 66 million years ago, Earth's orbit and the asteroid's orbit met at exactly the wrong place and exactly the wrong time. The collision became inevitable. The asteroid, roughly 10 kilometers across, raced toward Earth at a speed of around 20 kilometers every second. To the creatures living below, there was no warning. Dinosaurs wandered through forests. Small mammals searched for food beneath fallen leaves. Birds flew above rivers. Flowers swayed gently in the breeze. It was an ordinary day. The sky looked much as it had the day before. No living creature understood that within minutes, their world would change forever. Then the asteroid entered Earth's atmosphere. The air in front of it compressed so violently that it glowed brighter than the sun. A blazing fireball streaked across the sky. Moments later, it struck what is now the Yucatan Peninsula in present-day Mexico. The impact released an amount of energy almost beyond comprehension. The ground vaporized instantly. Rock melted. An enormous crater, more than 180 kilometers wide, began to form. A towering column of vaporized rock blasted high above the atmosphere. Shockwaves raced across the planet faster than the speed of sound. Forests near the impact vanished almost instantly. Earth itself trembled. Yet the greatest changes unfolded over the weeks, months, and years that followed. Countless fragments of molten rock were hurled into space before falling back through the atmosphere. As they re-entered, they heated the sky. Many regions experienced widespread fires. Ash and dust rose high into the atmosphere. Tiny particles remained suspended, blocking much of the sun's light. Days became dim. Temperatures fell. Plants struggled to grow without sufficient sunlight. Food chains that had taken millions of years to develop slowly began collapsing. The largest animals, requiring enormous amounts of food, were especially vulnerable. Many species disappeared forever. The age of the non-avian dinosaurs quietly came to an end. It is one of the saddest chapters in Earth's history. Creatures that had flourished for more than 160 million years vanished within a relatively short period of geological time. Yet even here, the universe reminds us that endings are rarely absolute. Not every dinosaur disappeared. The small feathered descendants that had already taken to the sky survived. Today, every sparrow perched on a fence, every eagle soaring above mountains, every owl calling through the night, carries a tiny piece of the dinosaur legacy. In that sense, the age of dinosaurs never truly ended. It simply changed its form. Meanwhile, the small mammals that had long lived in the shadows found themselves in a very different world. For millions of years, they had occupied modest roles in ecosystems dominated by giant reptiles. Now, many of those ecological spaces stood empty. Forests slowly recovered. New plants spread across the continents. The surviving mammals began exploring opportunities that had never before existed. Some adapted to climbing trees. Others became swift runners across open plains. Some returned to the oceans, where their distant descendants would eventually become whales and dolphins. Others learned to glide through the air before true bats evolved. Nature once again demonstrated its endless creativity. The earth itself continued healing. Rain slowly washed dust from the atmosphere. Sunlight returned. Seeds hidden beneath the soil sprouted. Young forests replaced those that had been lost. Life did not return exactly as it had been. Instead, it created something entirely new. Every great extinction in Earth's history has been followed by remarkable renewal. The planet never forgets, but it also never stops creating. As millions of years passed, flowering plants spread across nearly every continent. Bees, butterflies, and countless insects formed intricate partnerships with blossoms. Grasslands expanded across wide regions. The familiar colors of the modern world slowly appeared. Green forests, golden fields, colorful flowers, blue skies reflected in peaceful lakes. Earth was beginning to look increasingly familiar. Among the many mammals evolving during this time was a small group of tree-dwelling creatures with unusually flexible hands, forward-facing eyes, and curious minds. They spent much of their lives climbing branches, searching for fruit, insects, and leaves. At first glance, they seemed no more remarkable than countless other animals sharing the forests. Yet hidden within their growing brains was extraordinary potential. These early primates would eventually give rise to monkeys, apes, and, after an unimaginably long passage of time, human beings. The universe had spent nearly 14 billion years creating particles, stars, galaxies, planets, oceans, forests, and living creatures. The forests of Earth were changing. Continents continued. Plans could be made. Experiences remembered. Dreams described. Warnings given. Songs sung. The universe had spent billions of years creating atoms capable of forming brains. Now those brains had become capable of imagining the future. Eventually, our own species, Homo sapiens, appeared. Compared with the age of the universe, we arrived only moments ago. If the entire history of the cosmos were compressed into a single calendar year, modern humans would appear only during the final minutes of December 31st. Every civilization, every kingdom, every invention, every scientific discovery would occupy only the last few seconds before midnight. We are astonishingly young, and yet, in that brief moment, humanity has learned to cross oceans, build cities, compose music, write poetry, study the smallest particles of matter, and send machines beyond the planets. Perhaps our greatest achievement is not any single invention. Perhaps it is our ability to wonder. Wonder led us to observe the moon. Wonder inspired us to map the stars. Wonder encouraged us to build telescopes capable of looking billions of years into the past. Every question asked by a curious child continues a tradition that began long before recorded history. Who are we? Where did we come from? How did all of this begin? These questions have guided humanity across generations. And remarkably, the universe itself contains many of the answers. The atoms within your body were forged inside ancient stars. The calcium in your bones. The oxygen filling your lungs. The iron flowing through your blood. Every one of them has traveled an extraordinary journey lasting billions of years. In a very real sense, the universe has spent nearly 14 billion years slowly arranging those atoms into someone capable of asking about the universe itself. You are not separate from this story. You are one of its newest chapters. As humanity began to spread across Earth, our relationship with the planet slowly changed. For hundreds of thousands of years, humans lived as hunters and gatherers. They followed the rhythms of nature. They moved with the seasons. They watched animal migrations. They learned the behavior of plants, rivers, forests, and skies. Survival depended on understanding the world around them. The night sky was not just a beautiful sight. It was a guide. The positions of stars helped travelers find their way across unfamiliar landscapes. The changing appearance of the moon helped people measure the passage of time. The movement of the sun revealed the changing seasons. Long before modern science existed, humans were already carefully observing the universe. They were astronomers in their own way. They may not have known the names of planets or understood the physics of stars, but they looked upward with the same sense of wonder that continues today. The desire to understand the cosmos seems deeply connected to being human. Eventually, another major transformation occurred. Humans began cultivating plants and domesticating animals. Instead of always following available food, some communities learned how to grow their own. This change happened independently in different parts of the world. Fields replaced some wild landscapes. Villages formed. Populations grew. Human societies became increasingly complex. The first cities appeared. People built homes, roads, temples, and places to store knowledge. Writing developed, allowing ideas to travel beyond a single lifetime. For the first time, humans could preserve detailed records of their thoughts and discoveries. Stories that once existed only in spoken words could now survive for thousands of years. The universe had created creatures capable of remembering the past. Now those creatures began recording it. Civilizations rose along rivers where water supported agriculture and communities. The ancient Egyptians watched the stars and aligned great structures with the heavens. Mesopotamian astronomers carefully recorded movements in the sky. Cultures across the world developed their own explanations for the sun, moon, planets, and stars. Although many early ideas were incomplete, they represented something extraordinary. Human beings were trying to understand their place within the vastness of existence. Every observation, every measurement, and every question added another small piece to the growing puzzle. Over centuries, curiosity became more organized. Philosophers debated the nature of reality. Mathematicians discovered patterns hidden within numbers. Observers carefully tracked the movements of celestial objects. Slowly, humanity began moving from stories about the sky towards scientific explanations. One of the most important realizations was that Earth is not the center of everything. For thousands of years, many people believed the heavens revolved around our world. It was an understandable belief. After all, from the surface of Earth, the sun appears to rise and set each day. The stars appear to circle overhead. The ground beneath our feet feels still and unmoving. But careful observations revealed a deeper truth. Earth is a planet moving through space. The sun is a star. The stars we see at night are distant suns. And our world is only one small place among countless others. This realization changed humanity forever. It transformed our understanding of our position in the cosmos. We were not at the center of everything. Instead, we were part of something much larger, far larger than anyone had imagined. The invention of the telescope opened an entirely new window into the universe. For the first time, human eyes could see details impossible to observe naturally. The moon was not a perfect glowing sphere. It had mountains, cracks, valleys. Other worlds became real places rather than distant lights. The planets revealed their secrets slowly. Saturn displayed its magnificent rings. Jupiter showed enormous moons orbiting around it. The sun revealed dark spots upon its surface. The universe became larger with every discovery. Then came an even greater transformation. Humans learned that the stars were not simply tiny lights attached to a distant sphere. They were enormous objects scattered across immense distances. The sun was not unique. It was one star among billions. The Milky Way itself was not the entire universe. It was one galaxy among countless galaxies. Each discovery expanded the boundaries of human imagination. The universe seemed to grow larger every time we learned more about it. In the 20th century, another revolutionary idea emerged. Scientists discovered that the universe itself is expanding. Galaxies are moving away from one another because space itself is stretching. This discovery connected modern astronomy with the ancient story of the universe's beginning. The cosmos was not static. It had a history, a beginning, a long journey of transformation. The stars were not eternal decorations placed in an unchanging sky. They were born, they lived, they died. They created the ingredients for future worlds. And eventually, one of those worlds produced beings capable of discovering the story itself. Humanity had finally begun reading the universe's ancient diary. Every telescope became a time machine. Because light needs time to travel, looking farther into space means looking farther into the past. When astronomers observe a galaxy millions of light years away, they are seeing that galaxy as it appeared millions of years ago. The night sky is not just a view. It is a history book written in light. The stars above are messages from ancient times. Some of the light reaching our eyes tonight began its journey before humans existed, before dinosaurs walked Earth, before our planet even formed. Every clear night sky is a reminder that we are surrounded by the memories of the universe. And yet, despite all our discoveries, countless mysteries remain. What is dark matter? What is dark energy? Are there other forms of life among the stars? How did consciousness emerge from simple atoms? What will happen to the universe in the distant future? The story is far from finished. The universe continues expanding. Stars continue forming. Galaxies continue changing. And humanity continues looking upward, searching for the next page in the greatest story ever written. The more humanity learned about the universe, the more mysterious it became. Every answer seemed to reveal new questions waiting beyond it. The night sky, once a simple collection of glowing points, transformed into an endless ocean of galaxies, each containing billions or even trillions of stars. Our understanding expanded, but so did our sense of wonder. The universe became not smaller through knowledge, but larger. In the 20th century, scientists made one of the most profound discoveries in history. They realized that the universe had not always looked the way it does today. Galaxies were not simply scattered through an eternal, unchanging space. They were moving, and the farther away a galaxy was, the faster it appeared to be moving away from us. This discovery revealed something extraordinary. The universe itself was expanding. Space was stretching. The distances between galaxies were growing. It was as if the fabric of reality itself was slowly unfolding. This idea transformed our understanding of the cosmos. The universe was no longer just a place. It was a story with a beginning, a middle, and an unknown future. The light from distant galaxies carried another important message. When scientists studied this light, they noticed that it had been stretched toward the red end of the spectrum. This phenomenon became known as redshift. It showed that these galaxies were moving away as the universe expanded. The same principle can be observed with sound. When a train approaches, its horn sounds higher. As it passes and moves away, the sound becomes lower. The change happens because the waves are stretched as the source moves away. Light behaves in a similar way. The universe itself was leaving clues about its own history. Those clues led scientists backward in time. If the universe is expanding today, then in the past, everything must have been closer together. Much closer. Traveling backward through cosmic history reveals a universe that was hotter, denser, and younger. Eventually, we reach the earliest moments we can describe, the beginning of space and time as we know them, the event commonly called the Big Bang. The Big Bang was not an explosion inside space. It was the expansion of space itself. Every galaxy, every star, every planet, every atom, everything we know emerged from that incredibly early universe. The story of everything began from a state far simpler than the complexity we see today. From simplicity came diversity. From darkness came light. From tiny particles came stars. From stars came planets. From planets came life. From life came minds capable of wondering about the entire journey. As telescopes became more powerful, humanity discovered that our Milky Way is only one galaxy among an almost unimaginable number. The observable universe contains hundreds of billions, perhaps even trillions, of galaxies. Each galaxy contains countless stars. Many stars likely have planets. The numbers are so enormous that the human mind struggles to hold them. Imagine every grain of sand on every beach on Earth. Now imagine that each grain represented a star. Even that comparison may not fully capture the scale of the cosmos. The universe is vast beyond ordinary imagination. Yet among all this immensity, Earth remains special to us. It is the only place we know where life has definitely appeared. A thin layer of atmosphere, a moderate distance from the sun, liquid water covering much of the surface, a magnetic field protecting the planet, a complex history of chemistry and evolution. Together, these ingredients created a world capable of producing forests, oceans, animals, and consciousness. The universe spent billions of years preparing the conditions for life. Earth became one place where those conditions came together. The discovery of planets beyond our solar system added another fascinating chapter. For thousands of years, humans wondered whether other worlds existed around other stars. Then, in the late 20th century, astronomers began confirming planets orbiting distant suns. These worlds, called exoplanets, revealed that planetary systems are common throughout the galaxy. Some are giant planets larger than Jupiter. Some are rocky worlds similar in size to Earth. Some orbit their stars in places where temperatures might allow liquid water to exist. The universe appears filled with possibilities. Every new discovery reminds us that our solar system is not the only example of nature creating worlds. The cosmos seems to build planets wherever the conditions allow. Among the greatest mysteries in astronomy is the possibility of life beyond Earth. Given the enormous number of stars and planets, many scientists wonder whether life may exist elsewhere. Perhaps beneath the ice of distant moons. Perhaps in the atmospheres of faraway planets. Perhaps in forms so different from Earth life that we would barely recognize them. We do not yet know. The search continues. Robotic explorers study nearby worlds. Powerful telescopes analyze the atmospheres of distant planets. Scientists carefully examine every clue. The universe is still whispering. Humanity is still listening. But perhaps the most surprising discovery of modern astronomy is not only about what exists far away. It is also about what fills the space around us. For a long time, scientists believed the visible matter we could observe, stars, planets, gas, and dust, made up almost everything. Then they discovered something unexpected. The universe contains far more than what we can see. Most of the cosmos appears to be made of invisible substances and mysterious energy. Dark matter, dark energy. Together, they dominate the universe. Yet we do not fully understand either one. Dark matter does not shine. It does not absorb light in the usual way, but its gravity influences galaxies. Without it, galaxies may not have formed the way they did. It acts like an invisible framework holding much of the cosmic web together. Dark energy is even more mysterious. It appears to be responsible for the accelerating expansion of the universe. Instead of expansion slowing down because of gravity, it is speeding up. Something unknown is pushing space outward. The universe is not only expanding, it is expanding faster over time. It is a reminder that reality is often stranger than imagination. The cosmos is not required to fit comfortably inside our understanding. Instead, our understanding must continue growing to meet the universe. And still, after all our discoveries, one beautiful fact remains. Every person who has ever looked at the stars is made from the same ancient materials created by the universe itself. The atoms in your body are connected to the first moments after the beginning. They are connected to ancient stars. They are connected to galaxies that formed billions of years ago. You are not merely living in the universe. You are the universe, briefly becoming aware of itself. And as we continue our journey through cosmic history, there is still one final chapter waiting. The story of where everything is going. The future of stars. The future of galaxies. And the ultimate destiny of the universe itself. As we reach the end of this journey, remember that the universe is not just a story written in stars and galaxies. It is a story that includes every atom, every planet, every ocean, and every living creature. The same elements created inside ancient stars became the building blocks of our world. The universe spent billions of years creating the perfect conditions for a moment of awareness. And that moment is us. We are the descendants of cosmic events that began almost 14 billion years ago. Every breath we take carries a connection to the stars that came before us. Every night sky is a reminder that we are part of something much larger than ourselves. The universe is still expanding, still changing, and still creating new wonders. There are mysteries we have solved and countless mysteries that remain waiting for discovery. Perhaps the greatest adventure is not only exploring the universe outside us, but understanding the universe within us. So tonight, as you close your eyes and drift into sleep, remember that you are made from the ancient story of the cosmos. You are a small but beautiful chapter in a universe billions of years in the making. Rest peacefully, knowing that your story is connected to the greatest story ever told. Good night, and may your dreams travel gently through the endless universe.